Good morning. Thank you for coming along. So I'm going to be talking about AR wearables for enterprise, basically from the viewpoint of being a major supplier of components into this market, and what I see in the market, where I see the successes are, and where I think the market's going in the future. First of all, I should also say that I'll be talking about projections about future volumes. Don't use those as a basis for investing in Kopin, or at least don't tell them that I told you. Okay, so enterprise augmented or assisted reality, various different terms. Luckily, augmented reality and assisted reality both start with the same letter. So the sorts of systems I'm talking about here, just running along, we've got the RealWear HMT1, the Iristic unit. We've got the West Unitas, we've got the GoldenEye Infinity launched yesterday, going down to the bottom, the Vuzix M300, Google Glass, and then finally the Toshiba DynaEdge. So these are all units that, and I've got the M300 here, they're all basically of a similar configuration. They obviously sit on your head, and they have a display usually on one side that's on some sort of podded arrangement. And as one of the suppliers I was talking to yesterday said, these are not sexy. They're not pretty. They're pretty ugly, but the point is that they're functional. We supply the display for every single one of these products, and we pretty much have the majority, or pretty much all the market for display supply in this market. So I'm really going to talk about my experience having all of these companies as our customers. So why do companies want AR? It's pretty simple, actually. AR makes humans more powerful. It gives them access to information. It gives them access to data that they wouldn't normally easily have while having their hands free. And consequently, it improves their productivity. And basically, that's what it's about. If you talk to all the customers, all the end users, it's basically about improving productivity. It's pretty simple. It's not about making the guys look good. It's about improving their productivity. The other benefit of it is it addresses skill shortfalls. As probably many of you are aware, in a lot of industries, there is an eroding corporate knowledge within technicians and field engineers. And there's also lots of legacy equipment out there. So if you're a field engineer, field service technician, and you reach a piece of equipment that you're not used to, you've got a big learning curve trying to fix that piece of equipment. Using AR dramatically reduces that period, the time you will take to get up to speed on that piece of equipment. And there's a lot of industries, everyone talks about aircraft maintenance, and because it is a big market. It's not widely deployed yet, but it will be. And it allows companies to address some of their technician shortfalls. If you make your aircraft engineers more productive, you need less of them. And if you need less of them, you have less problem recruiting them and worrying about your reduction in quantity, the skills shortfall, trying to recruit technicians. So primarily it's productivity. Number two is you can address skill shortfalls, knowledge shortfalls amongst your technicians. And that's basically why companies want AR. And as we saw from the last presentation from HiScene, it's all about improving productivity. What I should also point out is, in Kopin, we're a long, long way from the end customer. And in fact, the hardware guys, we all tend to talk about the hardware because it's, well, I say it's not sexy. It is sexy because it's something you can hold. But actually, the hardware manufacturer is still quite a long way away from the customer. The people really driving this are the VARs, the software solution providers, the system integrators. And it's about providing a solution. It's about providing a productivity solution. So the people really in the driving seat are the people providing the software solutions. And to some degree, they don't really care which hardware they use, so long as the hardware they pick meets the requirements of that particular application. And different applications have different requirements. But we need to remember in this market that there's a very important layer of people between the hardware side of it and the customer. And really, the people building the smart glasses, building the wearables, are not actually in the driving seat here. It's the integrators, the solution providers who are in the driving seat. The other thing worth noting, and you can now see it, you saw it in the list I showed at the beginning, is that there is a wide variety of applications and a wide variety of form factors now available, choices that customers can make. You have tethered. At a sort of simplest version, you have tethered versus wireless. The tethered can literally just be a second screen. It's a pretty dumb bit of kit. It doesn't have any processor in it. It doesn't have any real capability within it. It's just replicating what's on the screen on your mobile phone or on your belt-mounted computer. An example of that is the GoldenEye Infinity, launched yesterday, and then 2 weeks ago, the Toshiba DynaEdge system. Both of those, the actual headset has very little functionality. It effectively acts as a screen to a belt-mounted processor, where all the complexity, the video processing and everything is all done on the belt. The other option is to go wireless and to go onto your head. And then you have to decide how much you put on there. You can go for what we call internally the thin client, where perhaps you just have Bluetooth. You can't stream video. You can't do lots of processing, but it allows you to make a very small, very lightweight product. An example of this, albeit in the consumer space, is the Solos cycling wearable. That is a very lightweight unit, but doesn't have a camera, doesn't have all the sort of heavy processing power. And then you can go up to the sort of full functionality. This is where you've got a processor on there. You've probably got Wi-Fi, as well as Bluetooth. You might even be able to make phone calls. You've got lots and lots of capability on the head. Now, why do you need all these different functions? Battery is a good one. Obviously, with the wireless one, the battery's got to be on the head. With the tethered one, you can keep the battery off the head. That's a pretty fundamental difference. If you go to fully functional, if you go to quite a heavy system but that has a lot of capability, you've got to put quite a big battery up there, as we heard earlier. You've got to have 8 hours. If you haven't got 8 hours use in enterprise, you're basically stuffed. People are not going to want your product. So the more you put on the head, especially if it's wireless, the bigger the battery gets, and then you've got implications in terms of how do you do the ergonomics, how do you produce a product that people want to wear. So there's lots of different choices, and often the application that you're using will define whether a tethered unit or a wireless unit is required, what the constraints are operationally on that. And then finally, there's the intrinsically safe question. Some environments, unless the product is intrinsically safe, you just simply can't take it into the facility. And at the moment, there's only one intrinsically safe product out there, which is the RealWear HMT 1Z1. And so basically, if you've got an intrinsically safe wearable requirement, you have to go and use that product because it's the only one that meets the requirements. So this is very much driven from the user requirements. There's not a one-size-fits-all on this. So I'm going to talk a bit about the RealWear HMT1. This technology was actually originally developed by Kopin in an earlier, more complex version of the GoldenEye. This is the HMT1 here. As you can see, it's quite a big unit, but it's very rugged. You can throw it around, drive over it, that type of thing. And this is designed for heavy sort of industrial use, outdoor, people who are in rugged environments. A fully capable system, hands-free, voice-controlled, display camera. You can do your remote expert. It's got a long battery life. It's got noise reduction. All of the technologies that you need if you're a field technician. You're going to put this on. You're going to go up a pole. You're going to be working on a piece of electrical equipment at the top of a mast or a pole. It could be raining. This is the sort of product you're going to need, something that's going to survive in that environment. You'll note it's very different from some of the perhaps sexier AR systems. It's not a particularly beautiful. It's a beautiful piece of engineering, but it's not a particularly beautiful bit of equipment to wear on your head. But it does the job and does it very well. And they're doing very successfully. Their volumes are pretty significant. So the HMT1 probably represents very much the sort of the heavyweight, all-weather end of the spectrum. Okay, talking about shipments. I've taken data from a whole series of different research reports here, really to try and look at where do we think the quantities are going to go. I've also, as we supply most of the units in the market, I can obviously also compare that with our own shipment data to make sure the numbers make some sense. So last year, somewhere around 25 to 30,000 enterprise wearables were shipped, somewhere in that area, roughly 2,500 a month. This year, the number looks to be north of 50,000, perhaps 50 to 60,000. So we're now up to probably 5,000 a month at the moment going into the market. Primarily from about 3 or 4 key companies. Next year, based on the track of a sort of roughly 115% compound annual growth, we're going to be well north of 100,000, probably somewhere around 125,000 units. So we'll be up to about 10,000 enterprise wearables a month. Now, as you see that progression, and I'm sure you've heard about people talking about all the pilots and pilot purgatory, 2017 was still very much pilots. I think Vuzix said they did something like 930 pilots or something last year. There was a lot of pilots going on. Now, the problem with pilots is that the end customer hasn't really committed. Someone buys 5 M300s or 5 HMT1s, and they're a big, rich corporation. That's not a commitment. That's just playing around. So it was possible that we could have all sort of stalled at that point. The good news this year is we're now starting to see real deployments. We're starting to see companies that are purchasing significant quantities and doing real deployments of equipment. Not that many yet, but they're definitely happening. And as we go into 2019, we expect that the real deployments, people like airlines and utilities companies, will have significant rollout of enterprise wearables. Now, this is throwing up a whole series of problems that people hadn't really addressed before. When you're doing a pilot, you don't really have to address how does the wearable work within the enterprise's IT system. When you go to deployment, suddenly the IT department get involved. And now you're talking about security and making sure it can't be hacked and all these stuff. How does it meet all the corporate security protocols? And that starts causing all sorts of challenges for the suppliers of solutions. So if you talk to the ones who are at the more advanced end of their company and product development, you'll find these are now new challenges that they're addressing. Nothing really to do with the display or the enterprise sort of hardware, but how do they fulfill, how do they tick all the boxes within the enterprise to allow them to be used within a secure enterprise IT environment. And then as we go forward, assuming the rate continues, we should be through 1 million units somewhere or an annualized rate of 1 million units sometime around 2022, getting up to sort of 100,000 a month by then, at which point they'll be very prevalent and you'll see them everywhere. Alongside the more generic applications, so most of what I've spoken about at the moment, everything I've already spoken about at the moment is for engineers and technicians, and that's the most generic and the most widespread application. There are, however, specialist applications. One that's probably not implementable in most Western democracies is having police who have wearables there that do facial recognition as they walk around, so they know who everyone is. However, there are parts of the world where that is acceptable. There are 1.9 million policemen in China, and potentially every one of those is a customer for a wearable that does facial recognition and receives information. And they've deployed it. They're doing it. It's actually happening in China. There are also some very specialist applications. That unit down below is a firefighter's helmet for a cruise liner. So these are not for firefighters who are professional firefighters, but it's for the crew to wear a smoke hood with an infrared camera and a display when they're if they find themselves in the position to have to fight a fire in a cruise liner. Very specialist market, That's a UK company, Halo. We supply the display for that. But there are all these little specialist uses. Probably the most interesting and well-known one of these is the Scott site. We've been working with Scott for, I think, about 5 years now. We worked with them about 3 years before they launched the product. They launched it about 2 years ago, and it's now widely used in fire departments in the US. So the Scott site is an update, it's an upgrade to their standard firefighter mask, SCBA mask, and it provides two extra components. It provides a thermal imaging camera, and it provides an in-mask display. And what this allows is it allows the firefighters to go hands-free, and it allows every firefighter to have a hands-free thermal imaging camera. So it's an assisted reality wearable product that enables firefighters to be more productive. So it goes back to all the same other reasons as to why you would do it. It means it's safer for the firefighters. They can clear the buildings quicker. They have more chance of finding any bodies faster within the building, and they can get out, which is obviously safer for them. And this is definitely not a science product. There's a science project. There are tens of thousands of these now out in use in fire departments all across the US. And there are other companies now also progressing with firefighter in-mask display products. So there's plenty of specialist applications. I haven't talked about medical. There's medical wearables coming into surgical theaters. They will be specialists. They won't be people sticking Google Glass on or HMT ones inside the surgical theater. They will have to be designed for the environment, for the requirements. There's all sorts of opportunities there. For example, wearables that show the video from the endoscope in the body while you're working on the patient. Again, it has lots of they have lots of requirements about ergonomics, about fatigue, and things like that, which they've got to address. So that's what I wanted to say. Talked about enterprise AR wearables. I suppose the summary, the takeaway is that there's two main markets. There's the market for technicians, engineers, people like that, working on all sorts of tasks to fix or build equipment. And then there's the more specialist ones like the firefighters, the police, public safety wearables. In both cases, the market is growing strongly. We're seeing shipments going up continually. And that's basically where we are today. If you have any questions, I don't know if we've got time, happy to take them.
Thank you very much, Greg. Again, we have time for probably one as we try to get ourselves back on time here. Anybody have, I don't know if there's a Slido question up. In the front again. Yep. Sorry, you're the guy.
What technologies should we maybe be paying attention to that might facilitate that sort of breakthrough product that's going to be a little bit more sensitive to human factors, perhaps a little bit lighter, thinking of things perhaps from a display technology standpoint? Is there anything that you can kind of disclose that we might be mindful of?
I don't think this hardware is currently really restricting the rollout. People can wear this. So the first level answer to your question is there's nothing here which is restricting the growth of the market. Going back to the point I made about the systems integrators, the pilots going into real deployments, that's currently the limiting factor, is getting the pilots to demonstrate the return on investment, demonstrate the productivity gains, so that you can then go from 5 or 10 units to 1,000 units across the enterprise. There's nothing technological in here which is stopping that happening. Now, are all these companies looking at improvements? Of course they are, but they're all generally incremental improvements. They're not really talking about radical changes. Now, having said all that, clearly waveguide technology is an interesting technology. It allows you to produce a smaller form factor set of glasses. But there's currently still quite a lot of technological challenges with that. Optically, it's far less efficient than this type of podded system. You've got to put a lot more energy into the light engine to make it work. And then that affects battery life and the size of your battery and all that sort of thing. So I think I think going back to saying the first level is the display, and actually the wearable hardware is not the limiting factor on rollouts. We can go from where we are today to 200,000 units a year without really any, if no one changed their products, we could still do that. There's nothing stopping, nothing from the hardware side stopping that happening.